Okay.
All right, good morning. They're more awake now. It's improving. Each time it gets a little louder, a little louder. All right, so a couple housekeeping things. Please don't block the fire exits. I think we'll be okay with that. Cell phones, shut them off, silence them. You know the drill. I did wear boots today. Don't make me have to come out there and use them. All right. So, you guys are in Ballroom C. This is the anything track. If that's not where you thought you wanted to be, we're locking the doors. You're stuck here anyway. Because you're going to love this next talk. We're talking about malware. So this is us destroying everything, and I'm going to turn it over to you.
Okay, good morning, everybody. So apparently my talk title is Destroy Everything. It was supposed to be entry-level malware writing, but Chris is deciding to troll me. So for everyone who actually showed up to this, I don't know why, but thank you for coming. So my name's Tom Somerville. I'm a security engineer at Gordon Food Service here in the Grand Rapids area. I don't really have any social media or participate in any of that. So if you want to get in contact with me outside of the conference, just come up, get to know me in person. I'm a very approachable person, and I can get you that stuff personally. So what are we actually going to be talking about? So as my title slide said, we're going to be talking about some entry-level malware. The goal here is to kind of demystify coding, malware writing, and kind of remove that veil of, like crazy eliteness that a lot of people tend to have. I know just, very recently, I always used to think that, if malware gets dropped in my environment and I'm taking a look at it, like there's got to be doing some like crazy like obfuscation and like NSA style evasions to get this stuff past like antivirus, and like that's not the case. Like these people Google all the same stuff we do. Really the only difference is that they have persistence and they keep through it during the bug squashing. So I'm going to we're going to write some real malware. I think you should be able to go home and do this still. It worked on Defender this morning, so, and I'm just going to kind of walk through that process of what's going through my head so you can kind of see what a real development lifecycle looks like and maybe feel a little more confident to go home and try it yourself. So, what's the environment look like? Not anything too special here. We're going to be using Python 3.7. I'm going to be using a program called PyCharms, which is kind of like Python equivalent to Visual Basic. Visual Studio. I'm going to be using some DNS, so I got Google domains for my DNS host. And we're going to be using an Ubuntu server, so it's just a basic EC2 instance in AWS default Ubuntu. So I'm not actually going to cover how to set these up. There's tons of tutorials on them. I am doing everything just base install. There's no fancy configurations with this, so I'll let you do that yourself. How do we want to code this? So before I actually put my fingers on the keys and write some code, you really want to know kind of like what you want it to do. You don't have to have it like all fleshed out perfectly. But for me, I want this sucker to receive commands remotely via DNS queries. I want it to execute those commands on the victim box and then send us the execution results in a log file to our server. So that's what I'm going to be working towards. And to start, we're going to do the DNS query as our first goal. So I'm going to go over to Google Domains, and I'm just going to create a text record for my domain, thomassomerville.com. It's going to be grrcon.thomassomerville.com, and the value of that text record is just going to be dir. For those of you who don't know, dir is basically like the ls equivalent for Windows. It just lists the contents of the directory in shell. Okay, so how do I figure out how to do this? Well, this is actually how most people figure out how to do this. They type it into Google, and then they look at Stack Overflow. And you can tell I actually did this because that link is purple. So I go over to Stack Overflow, and I look at a guy who's smarter or spent way more time than I will, and I copy his code and put it into mine. And this is no joke. This is real. Of course, I take his example domain out of that example and substitute my domain with it. And then I hit run, and I get an error message that says no module named DNS. Well, it didn't work. This guy's wrong, right? Well, it turns out in most programming languages, or at least all programming languages I'm aware of, they have these things called libraries or modules, and Python calls them modules. Essentially, these are just a bunch of code other people wrote to make things easier for me, so I don't have to rewrite that code. So some dude spent way too much time trying to make DNS queries in Python easy, so I don't have to spend all that time. So I just do import DNS, and I can use his code in my code. And this is how it works. Not all these libraries come installed by default in Python. Some of them I have to manually install. Some do come default in Python because they're just so popular, or the developers really like them for some reason. And so luckily, Python makes it very easy to install these modules that do not come by default. And it's a program called pip, similar to downloading an app on your iPhone. In Python, I just do pip install and then the module name. It will go out to Python's repo, download and install that into my development environment, and now I can use it. So if I take that same code and run it again, I should be okay. Now, you see here I add an extra line. It's just a print statement. The reason you have to do this is because I actually want to receive and store the query results, that dir, but I'm storing it into a variable called results. So results equals DNS resolver query, right? Unfortunately, I'm not going to actually see the results of that query unless I actually tell Python, spit it out on the screen. And it's very easy to do. Just do print, and then in parentheses, you put what you want to be spat out onto the screen. In this instance, that variable that we stored the query results in. So print results. I hit run. You can see dir at the bottom, which is what we put in DNS, and it looks like it's going swimmingly. So let's take this command that we just received via DNS and run it on the local box. So here we go. Step 2, Google it again. And so you can see Stack Overflow link is purple. You grab that stuff, put it into my code. In this instance, the guys on Stack Overflow say an easy way to do this is to use a module called SubProcess. So import SubProcess up at the top, and then I'm just going to do subprocess.run, and it takes one required argument, which is the command you want to run, but then it has any number, a whole bunch of optional arguments. We're going to use one of these optional arguments. We got this from Stack Overflow. Like people find it fun to just discuss this on the internet. So I profit from that, and this optional argument is just shell equals true. This basically tells that subprocess module, run this command in the host's default shell. In our instance, this command prompt. And if I hit run, you can see, those of you familiar with the Windows environment, spits out the directory that it's executing from, just as expected. So I now have some code that is reaching out, getting a command via DNS, executing that locally in the box. So I want to send that command output to myself at my remote server in a log file. So we're going to store that in a variable called cmd. So it's just cmd equals subprocess.run. We'll add that print statement again just for development purposes so I can ensure that it's working. And we're going to work towards doing that log file. But before we do that, we're going to create a loop here. So most of our employees will be nice enough to click on that malware for us once. But if we call them up every time we have a new command that we have issued in DNS, they're probably eventually going to, get suspicious, maybe around the 8th or 9th time. So we're going to create this loop so it will always stay running and just periodically recheck for that command. But before I do that, I'm going to organize my code to make this loop writing easier. So in Python, there's these things called definitions, and it allows me to create these code blocks. This is there's a lot of reasons why one might want to do that, and the main reason I want to do this is twofold. One, it helps me organize my code based off a function. So here we kind of have two main functions. One, the DNS query. Two, the code execution from the query. So I'm going to split this out across those two kind of thought blocks, and then I can use these definitions to call all these bunches of lines of code. I mean, there's not a bunch here, but there will be in a second. from all over my code. And then the second reason why I would want to do this is a lot of times I'm going to build out some functionality and I'm going to want to use it in multiple spots. And I could copy and paste, that function, the code functionality all over the place. But if I want to slightly change how that works, I now have to go edit that in 8 spots. And this kind of avoids that. Everything lives in one spot. And to simply run all the code that's underneath that definitions, I just type in that definition name, which we have DNS request and exec command as the definition names. Just type that in, and Python will jump back up, run that code, and then go right back to where it was for us. And you can do this all over your code, so it helps it keep it both organized and shorter and cleaner, which is really good for me, at least. Okay, so let's talk about this loop. We're going to do a while true statement. So a loop is basically something that checks if a condition is true, and if it is true, it does the things below. And then it repeats to check if that condition is still true, and then it will do the things. So we're going to do what's called while true in Python. Essentially, we're saying, well, check to see if true is true, which it should be. Do the stuff, and then recheck to see if true is still true, which it should be. So do the stuff again. So assuming no glitches in the matrix, this should repeat indefinitely. So we click it once, and it will run our code over and over and over again forever until they end it. They find it and end it. So at the bottom here, we're going to have this while true loop, and you can see how I call those definitions that I created. So it's just while true, and then right below it, we're going to do the DNS request, and then we're going to execute the commands from the request, and then we have this new function here. It's going to be time.sleep. So I want to pause this loop every 30 seconds so that I'm not, doing a DNS query and running that command like 60 times a second. It'll probably spike up their CPU, generates a lot of traffic. It's going to be super easy to see. So we're going to use a new module that comes with Python by default called time. So we're just going to import time. This allows us to use time.sleep, and then in the parentheses there, we can just pick any number of seconds that we want to sleep. I just picked 30 because it was short enough for testing. If you're going to use it in a real environment, you may maybe pick a couple hours or something. Okay, and so when we run it, it blows up. So why did it blow up? It was just working before we did this definition in the loop. And when we run into these things called private variables. So if you look at the error message, it's saying that subprocess that run cannot find the variable results. So it breaks because it's got nothing to run. But if you look, results is just in the definition above. Well, because we've moved our code into these things called definitions, variables are what are called private by default. And so results is only available to the code inside of that DNS request definition. Now, if I want to make this variable accessible to all my code globally, Python gives us an easy way to do that. And I could just manually declare global space variable name. And now that variable, Python will let other pieces of my code outside that definition query it. And then you can see that the code now is running successfully, still using that dir command from DNS. Okay, so this code's running every 30 seconds for us, every single time. Now, I probably will not, let's say I issue a download command. I'm not going to want to download that one file to this box every single 30 seconds, right? I kind of only want it to run the command once and then just sit there and wait for a new command. So I'm going to implement a little check in that loop to make sure that the command that I just received via the DNS query is not the same as the one that he just ran. So first, I'll create a variable to store that old command in. We're going to call that cache results, and we're going to make it equal to none. This is Python's way of saying null or nothing. From there, I'll move down into the loop, and I'm going to implement an if check. Essentially, what I'm doing here is saying if that cache results variable, which will be the old command, is not equal to the newly requested command, then run the command. So we're just making sure that they're different. Assuming that they're different, it's going to do the exec command definition, which is going to run the query against the box. And then it's going to update that cache results variable with the command that it just ran. So then when it reloops, it's going to do that check, and this time cache results will be equal to that command, assuming I didn't update DNS. And it's just going to skip that whole if statement block there that's highlighted and go right down to time.sleep. And this will just keep skipping command execution until I update DNS. Okay, so we got some working stuff essentially, right? I got remote command execution on a victim box, but I can't see anything. So let's get the command execution logs over to me. So I really struggled trying to find a simple way to set up this web server. It ended up being like a 15-minute tutorial on how to properly configure an Apache web server. And this is a 25-minute time block, so that wasn't going to work. So Python comes with something called the Simple HTTP Server. It's awesome. Everyone should go play with it. Unfortunately, this only supports GET statements, which allows us to download files from it, but we can't upload files to it. This person, Floating Octothorpe, whoever they may be, wrote some pretty awesome code that basically imports that simple HTTP server and extends the functionality to support put statements. So now I can download files from it and upload files to it. So I'm going to SSH into that AWS Ubuntu server, copy and paste his code into a file called server.py, and then just run Python space server.py. And now I have a running web server on my box. Assuming the firewall isn't blocking traffic, this is a dev environment, so just turn the firewall off, right? You can see that when I navigate to my server here, I have a very rudimentary web server. And we'll do a curl statement to just test the put functionality. We pop over and we can see that the put was received by the web server and that it did indeed write the file to the server with the content correctly. So let's figure out how to upload a log file to this web server in Python. Well, there you go. Purple Stack Overflow link. Anyone seen a pattern here? Okay, so my code's getting a little long, and in order to facilitate the testing, I'm doing something new, and I don't want to break my code and make the bug fixing process complex. So there comes a point where it's just easier to try this out on the side. So I'm going to create a new script, and I'm going to do what Stack Overflow says in this new script first, get it working, and then come over and just kind of smash it into my main code. So we're going to do pip install request because Python says the request module is the way to, Stack Overflow says the request module is the way to go. Import the request module, and then following the stranger's advice, just create variable with text. This is going to be the content of the file, and we do this request.put statement. It has two arguments here. One is the web server /file that I want to upload. Two, and then the second argument is data equals what I want that file to contain. So in this instance, that text variable. And I hit run. You can see in the web server that I get a successful put state in the web server logs, and the file is written to the server correctly. So let's smush this into our main program here. Now, I could put this inside of the loop, and then every 30 seconds I'm getting a log file, regardless of command execution. And I don't necessarily want that. Less traffic is better, right? So I'm going to actually, since we already have that check for the unique command execution only built into that loop, I'm just going to throw this log upload inside of the command execution definition right there at the bottom. That way, whenever the command is executed, I get a log, but never any other times, which is what I'm going for. So import requests up there at the top, and then I can just copy and paste that over to our environment. But instead of just some random variable with a string I put in for testing, we're actually going to have the contents of that log file be the output of that command execution. So in this instance, that variable is cmd, and it blows up again. Well, it's just working. So hour of Googling later, and it turns out that Python has this, what's supposed to be a little helpful feature, sometimes gets in the way, where it auto detects the type of variable that it is. So in a lot of languages, you will specifically declare that this variable is a string or this variable is an integer. You don't do that in Python. In Python, you say this variable is equal to 4. And Python goes, well, it's probably an integer, so I'm going to treat it like an integer. In this instance, it's working against us because the output of that subprocess.run command contains multiple fields. It's treating it like an array, and the put statement here is not able to populate that uploaded file over an array, so it crashes out. Well, luckily for us, Python also makes it very easy to correct its own mistakes, and I can just redeclare a variable as a different type by wrapping it in that variable's declaration here. So we can see I just wrapped that command CMD variable in a parentheses prepended with str. And now Python will just always treat that as a string just in this one instance. And then we can see here, when I rerun it, looks like it worked. Go over to the web server, and sure enough, I got a log file. So let's do some tests. Change the command in DNS back to dir. And I do the put statement, echo it out, and it's not exactly what I was looking for. So it tells me what command run and that it ran successfully, but I'm actually kind of going for, like, I actually want to see the contents of that directory, not just know that I'm capable of looking at it if I happen to be there. So what's going on? Well, if you remember back when I was initially talking about that subprocess and how there's a number of optional arguments, well, there are some other optional arguments that allow us to capture what's called the standard out of that command prompt execution, and I can store that into a variable called stdout, standard out. And that will store the output, the actual content that I'm looking for, not just the command I executed, but actual all the files and folders output into a variable called standard out inside of the variable called CMD. And then because unfortunately it receives this as raw bytes, we also have to add a second optional argument which decodes this as UTF-8 so that like humans can read it, because raw bytes are not human readable for most people. And so I have the option here to just send all of command, and I get everything. The command, if it was successful or not, what command it ran, and all the content, or if what I'm looking for is just the actual standard out of that command execution. So we can do something here where I just say, in the command CMD, we can put a dot and say, only give me the data of this subvariable, in this instance, standard out. So CMD.standard out is what I'm going to send in my log file instead of everything there. When we rerun it, we can see that the log file actually has what we're going for. So let's do some more tests here. Now I think I got it working. This is a download statement, so we can download PuTTY to the box. And when we run it, we can see looks like it executed correctly in Python. I get the put statement in my web server, and if you look up at the top left-hand corner, really tiny, like in the Explorer view that PyCharms gives us, you can see that putty.exe was downloaded to the box. So let's go ahead and read PuTTY. And you can see after it recognizes that the DNS has changed, it launches that program that we just downloaded. You can see how this could be useful, right? I guess not. Okay. Okay, so let's compile this so that we can actually send this over, because I'm assuming the victim box is not going to have like a fully functional Python development environment. And I want to target those people. So we're going to compile this into a single binary that we can send to any Windows system. So once again, Stack Overflow tells me that PyInstaller is probably the easiest way to go. So I can do pip install PyInstaller, and then I can run pyinstaller-f-w, and then I can tell it the Python code file that I want to compile into an exe. In this case, it's sassypants.py. So the -f statement here is basically saying all those imported modules by default aren't bundled up with the exe file. These are dependencies that they're going to assume you're going to deploy on your own. So if you are a heavy Python shop, you can deploy those dependencies once, and then all your in-house developers can just compile their code, and your binaries are much smaller overall. In this instance, I'm going to assume they don't, so I want to bundle everything into a single exe file during the compiling. And -w here is going to hide console output, so when I run this sucker, it's going to be hidden, and it's going to be running as a background task. So when I run it, you can see sassypants.exe there, and it crashes. So it's working pre-compile and not working after compile. So once again, Google. And it turns out that PyInstaller requires anytime you use SubProcess, you have to redirect all of the possible SubProcess returns from that pipe. Those three things are standard out, standard in, and standard error. So, getting things returned from that execution, sending things to the execution, and then if there's an error message, error catching. I already have standard out declared here and redirected, but I don't have the other two, and I don't really care about those. So in this instance, So I'm going to create a new variable called fnull, and I'm going to make that equal to os.devnull. Devnull is this wonderful little black hole that doesn't really exist, which its sole purpose in life is just to redirect the output you don't want or don't care about to nowhere. Most languages have this, even Bash, and Python's no exception. So now if I add in standard error and standard in equals devnull, or fnull, and redirect that to the black hole, recompile, that sucker is running now. And you can see here there's no window on the taskbar at the bottom showing that this sucker is running. You can see it running in Task Manager, and then also you can see that that download putty command successfully downloaded that binary to the victim box. Okay, so there you go, you're done. In reality, this is designed for a very narrow scope. If you take this exact code and you try to deploy it, let's say on Vista, no promises it's going to work. So I'm going to let you do the additional testing for your personal environment. But yeah, that's basically all it is. So the goal here was really to kind of break down the scary unknown aspect of, making malware. You receive malware and it does bad things. So, like crazy elite people must do it. And I kind of want to lift the veil for all of us in the room here and say, this is 23 lines of code. 5 are just importing other people's code, and 3 are blank lines. Yeah, it's cool, and it's going to take you a little time. I ran into tons of bugs, and I spent a ton of time Googling, but it is definitely achievable. And I think that after I kind of saw the development process of malware, it made it less mysterious and less scary to be the reverse engineer of that malware. And and also it's a heck of a lot of fun. So that is the whole talk. Do I have time for questions? Or no time for questions. So I'll be outside the room if you want questions.